Hey guys, HackerSploit here, back again with another video. I apologize for the lack of uploads. Things should be okay now, so normal uploads should resume. In this video, we're going to be exploring the process of exploiting the dirty pipe vulnerability that affects the Linux kernel. So this is a local privilege escalation vulnerability. So dirty pipe, as the name suggests, is very, very similar to the dirty cow privilege escalation vulnerability that was released earlier on. So this is pretty much one of the latest Linux privilege escalation vulnerabilities or exploits. The CVE code for this vulnerability is CVE-2022-0847. All right, so it's essentially the latest vulnerability that affects the Linux kernels from version 5.8 and newer. As I said, it's very similar to the dirty cow privesc vulnerability, which is where it gets its name from. The vulnerability was discovered by Max Kellerman in April 2021. However, he was still trying to figure out what caused the vulnerability and how it could be exploited in a through a plethora of techniques. So the way it works is that it allows the overwriting of data in arbitrary read-only files or the process cache or memory of a specific SUID binaries, which can consequently lead to local privilege escalation. This is primarily because unprivileged processes can inject code into root processes. All right. As for the actual vulnerability itself, this vulnerability was fixed in the Linux kernel versions 5.16.11 or 5.16.11, 5.15.25, and 5.10.102. So it affects pretty much the latest versions of the Linux kernel, or at least versions of the Linux kernel from version 5.8 and newer. Now, what I've done to demonstrate this is I've set up a GitHub repository. It's the link to this GitHub repository will be in the description section, so you can check it out. The reason I created it, you might be asking, is primarily because this particular exploit or vulnerability really has been quite difficult to explain, and both in terms of how it works and in terms of how it can be exploited. So you can see that this GitHub repo contains two exploits, one called exploit 1 and exploit 2. Now, I do not take credit for these exploits. A majority of them, or both of them, really have taken the original source from Max Kellerman's original disclosure. So if you want to learn more about the original disclosure, you can take a look at this link here. So that's dirtypipe.cm4all.com. As you can see, this essentially explains the actual vulnerability in depth and what elements of the Linux kernel you're going to be exploiting, right? And I'll try and explain it as best as I can. So the GitHub repo contains information regarding the actual vulnerability, the affected versions of the Linux kernel, and the versions of the Linux kernel that have been patched to fix this issue. As I said, there's a couple of other ones, but as soon as I get that info, I will be posting that. I've also added the link to the MITRE, the CVE.MITRE webpage that essentially contains information regarding this particular CVE. So again, you can also learn more by taking a look at the CVE details. And, that'll give you an idea as to what the vulnerability looks like from a threat perspective or from an impact perspective. I'll probably be making another video that covers how to patch this vulnerability, but it really is very, very simple. All you need to do is, in the case of Debian and Ubuntu, I believe there are already updates or patches. So you just need to update, to the latest version that you have within your repositories. And I've also added, a section that essentially covers a vulnerability scanner that will essentially check the target system and see whether it is vulnerable. So the credit goes to this author here. So you can see it's called the Dirty Pipe Checker. It's really very simple to use. It's just a simple shell or bash script, if you will. And you can see that it essentially allows you to check whether the target system is vulnerable, or you can check a specific kernel version to see if it's vulnerable. Now, for the target system, I just downloaded a VM from osboxes.org, and I believe this is Ubuntu version 20.04. Let me just, so cat etc issue 20.04.3, and the kernel version is version 5.11.0. So that fits within the parameters of the affected versions of the Linux kernel. So you can actually see how powerful this is. And, one of the really cool things that I was exploring over this week as I wanted to understand how it works is this exploits or this vulnerability's impact on CTF challenges. So, you know, there's tons of CTF challenges on Hack2Box, on TryHackMe that have versions of Ubuntu that utilize, you know, kernels within the affected range. And you could potentially use this exploit to gain root access, even if that wasn't intended. So what we'll do firstly is I've already cloned both of the repositories on my desktop, as you can see here, and I'm currently using an unprivileged user called developer. So I'll just cat out the contents of the password file. There we are. So you can see we have the developer account here. That's the one I'm currently using. And of course, we have the root account there. And what we can do is let me also show you that I'm not part of the sudo group. So we'll say groups developer. And you can see I'm just part of my own group. So this is an unprivileged user. So I can say sudo apt-get update, for example. And, you know, I'll put in the password there. And you can see developer is not in the sudoers file. All right, so this is a totally unprivileged user. Now, as I said, I've added, cloned both repositories on my desktop. So let's start off with the vulnerability scanner. So I'll just say, you know, cd into the dirty pipe checker GitHub repo here. And I'll just say chmod +x. Let me type that in correctly, dpipe.sh, and then I can say dpipe.sh. So if you run it by default without specifying any arguments, then it'll check your current Linux kernel version, and it'll then tell you whether it's vulnerable. So, you know, you can actually explore the code yourself. It's fairly simple. You can see that, you know, it'll essentially run a check. So, you know, it'll utilize the uname utility, and it then passes it or utilizes the cut utility to filter through the data and get, you know, the actual kernel version, and, you know, it just cleans it up a little bit. And then, of course, you know, it has, you know, version 1, version 2, and version 3 variables, and then it performs the checks here. So we have an if statement. If it doesn't match any of the following parameters, then it tells you that it's not vulnerable. If it is vulnerable, it tells you echo vulnerable. All right, so very simple there. So I can say dpipe.sh, and you can see 5.11.0 is indeed vulnerable. As I said, you can also check other versions. So I can say 5.13 vulnerable. If I say 5.10, and if I use one of the affected versions, so 5.16.11, so let me just say that 5.16.11, not vulnerable. So it works really, really well. And yeah, it's very, very helpful. So we know that this target system is indeed vulnerable. So I'll navigate into my GitHub repository that I cloned. It's called Dirty Pipe Exploits. Both of these will be in the description section. So you can see that you will be provided with, you know, the following files. You'll have the compile bash script that will compile these C exploits for you into binaries. You do need to have GCC installed. So that's just one additional step that you need to perform. And you can go through the documentation, right? So we've already performed the vulnerability scanning. We can talk about exploit 1. All right, so before we do that, let's actually compile both of them. So I'm just going to say, we'll say compile.sh, and we'll give that a couple of seconds. And if we list out the contents of this directory, we now have exploit 1 and exploit 2. So these are the binaries there. All right, so exploit 1 is the one that you should already be aware of. And this is essentially, this exploit code was taken from, this proof of concept rather was taken from Max Kellerman's original code. However, it's been modified to change the root password in the etc password file, consequently providing you with access to an elevated shell. So once it's compiled, you can see that, you know, you can run it as follows. So the exploit code has already been configured to replace the root password with the password called piped. So that's the password that I've configured, and we'll take a backup of the etc password file before it begins, and it will save it under temp password.back. You know, furthermore, this exploit will also provide you with an elevated root shell and will restore the original password file when done. So it's really fantastic. You can actually take a look at the exploit code here. So I'll say exploit 1.c. And it's really very simple to use. As you can see, this is the original code by Max Kellerman, and I've made a few modifications here. So this does not need, you don't really need to pass in any arguments or, you know, anything else. All you need to do is just run it. And I'll explain how that works in a second. So you can see that we have the main function here, which, you know, we have the etc password, the path to the etc password file or the password file itself. It takes a backup. And after that is done, you can now see that under the same function, after the root user account, it'll then add the following salt for the root user. And the password that was used in this case, or the salted password in this case, as you can see, is called piped, or rather the unsalted password is called piped. So what you can do, there's an OpenSSL instruction or command here that allows you to generate your own salted password. So, you know, for example, if I copy this here, and let me just copy that there correctly, and I'll open up a new tab here, and I'll just paste that in there and hit enter. That'll generate it for you. Now, as I said, in this case, what has been done is, because the algorithm is using SHA-512, you need to change that to 6 instead of 1, which is MD5, based on the target system you're working on. So there we are. So if I change the password to maybe whatever you want, maybe, you know, password 123, that's the new salt. So all you need to do is just replace this value within the code there. As you can see, it's going to set the root password to piped. Once that is done, this is essentially where the exploit comes into play, and I'll explain that in a second. And then, of course, at the bottom here, you can see that it's going to pop a Bourne shell session, of course, as the root user, because we know it's going to change the root user's password, and then it's going to restore the original etc password, you know, from that was stored in the temp directory. It was called password.back. So that we are done popping shell, and you know, it essentially opens up a Bourne shell session. You can of course modify this to give you a bash session, but at least in my experience, it works really well with a standard Bourne shell session. So I'll just quit and exit, and let me explain a few things now. So how does this vulnerability, or how does this exploit work? All right, so this vulnerability is primarily caused due to an uninitialized pipe buffer flag variable, which essentially overwrites any file content in the page cache, even if the file is not permitted to be written, or if it's a read-only file, or it's a, you know, a CD-ROM mount, etc. Now, this is because the page cache is always writable by the kernel. So that's very important, right? And writing to a pipe never checks any permissions, because the reason for that is primarily because pipes, you know, whenever you use a pipe to redirect output, you know, the Linux kernel already assumes that the person using the pipe already has permissions. And of course, that makes sense, because if I use a pipe as the developer user account, then, you know, it essentially knows that, you know, that is being used by the developer user account, right? So writing to a pipe never checks any permissions, or, you know, performs any permission checks. This essentially allows attackers to, you know, perform privilege escalation by essentially overwriting the data in the arbitrary read-only files and injecting code or your own data from an unprivileged process into a privileged process, right? So the way this exploit works, the way exploit 1 and exploit 2 work, you know, at a very high level is the following. So it essentially creates a pipe, and I think I can highlight that here because the code was very well documented. So there we are, creates the pipe where all the buffers on the pipe inode info ring have the pipe buff flag can merge flag set. All right, so it'll essentially create the pipe and send data into the pipe. This will ensure that, you know, the pipe buff flag can merge flag has been set for the pipe buffer. It'll then drain the actual pipe. Let me see if I can highlight that there. So there we are, drain the pipe, freeing all the pipe buffer instances, but leaving the flags uninitialized. So the flag it's leaving uninitialized is the pipe buff flag can merge flag. All right, so the issue here is, you know, is really to do with this particular flag. All right, so you can see it says that this pipe is now empty, and if someone adds a new pipe buffer without initializing its flags, the buffer will be mergeable. So if a buffer, you know, if a pipe buffer has the pipe buff flag can merge flag, then you know, if it's set for all pipe buffers, then and it's not reset, then you can essentially utilize the splice utility or the splice function on Linux. So, you know, you can essentially, this exploit will then splice data from the read-only file into a pipe that has that flag set. The pipe buffer with the actual flag, the pipe buff flag can merge flag, contains a reference to the data that has been piped earlier. So that allows us to essentially write data to the pipe buffer, consequently overwriting the content of the referenced file. And of course, this happens because write permissions are not applied to pipes. So I know that may be a little bit confusing, and I will be having a write-up that explains it. But, you know, if you really want to learn more about this vulnerability, I definitely recommend taking a look at the write-up by Max Kellerman, which is actually fantastic. It took me a couple of days to understand what was going on, but the possibilities here are really, really cool, from an attacker's perspective. But from a defender's perspective, this is really, really dangerous. So that's why I have 2 exploits to highlight how useful this can be. So as I said, exploit 1 is fairly simple. It will essentially replace the root user account password with our own, which is piped. You can modify the code if you want. So I can say exploit 1, and I don't need to provide any arguments. So I can just hit enter, right? And I'll hit enter. There we are. And you can see it's going to back up etc password to temp, and it'll store it as a file called password.back. It's going to set the root password to piped. Password, restoring the etc password from temp password.back. That's a great thing. And then of course it says done popping shell. You can run commands now. So if I type in ID, you can see I now have a bash session or a bourne shell session with root privileges. And if I open up a bash session here, you can now see I've elevated my privileges to root. Now, one important thing that I didn't point out is, let me exit, right? And I'll actually show you, something really, really interesting. So the password file is non-writable, which, you should know by this point. So, if I try and echo, just some test data into etc password, you can see permission denied. So we're essentially modifying that file. So when we run this exploit, it essentially modifies the file, adds in the actual salt that we specified for the root user account. It then provides us or authenticates as the root user, provides the password, that we specified, or rather utilizes, the actual password, which in this case is piped, provides us with a shell. And then, of course, once that is done, it then restores the original password file. So, for example, if I say cat etc password now, you can see that the actual root user account has not been modified. That's because the original password file has been restored. So LSAL under TMP, you should see that we have password.back there. So, really, really is cool because it cleans up everything for you. So again, I'll just run it again. And there we are. So you can see I can now, I'm now the root user. So really fantastic stuff there. All right, so that's exploit 1. We then have exploit 2. So exploit 2 is, in my opinion, where things will really start getting interesting, especially from a CTF perspective. Right, so exploit 2, there we are. That is essentially entails to hijacking the SUID binaries. So this exploit code actually obtained from the following Github repo, so you can actually check it out for yourself. And the way it works is really very simple. As you can see, this exploit can be used to inject and overwrite data into read-only SUID process memory that run as root. So, of course, you can find SUID binaries by running the following command, which we should know, or you should know already. And, I can also say, for example, sudo l. Let me just put in my password there. You can see the developer may not run, run sudo on OS boxes. So, I can essentially say or paste in the command there to find SUID binaries. And in this case, the only one that we can use, and, we're not really talking about exploiting a SUID binary. We're essentially, just talking about exploiting a standard, a standard SUID binary that you typically have on Linux, like sudo, for example. So we can exploit user bin sudo or utilize that SUID binary. So as the instructions specify on the GitHub repo, exploit 2 user bin sudo, and that should provide us with an elevated session or root shell. So there we are. We can see we have, there we are. There's the SUID binary. So I can now say exploit 2, and then, I can say user bin sudo, hit enter. There we are, hijacking the SUID binary, dropping the SUID shell, restoring the original SUID binary. And there we are. So it says popping the root shell. And of course, don't forget to clean up temp sh or the bourne shell session. So I can say ID. There we are. So we've elevated our privileges successfully. And of course, you can open up a bash session if you want. All right. So that is essentially how to exploit the dirty pipe vulnerability, or how to utilize the dirty pipe exploit to elevate your privileges on Linux. As I said, the effects of this vulnerability are really far-fetching. Primarily because, especially in the case of Debian and Ubuntu, I do know that it took them a while to release the patches, and it took a couple of days for them to do that. So this is something that's really dangerous. And then, of course, the other issue that I realized is not a lot of people have actually covered this vulnerability, which is really, really weird, because, I'm looking at it from the perspective of an attacker and also a defender. And, if this is not given any recognition, or if you're a defender, or, if you work in the blue team and you're not aware of this vulnerability because, it really hasn't been covered like the others, then you're going to be at a disadvantage, because you could have this, you could have a server unpatched, and all it takes is just for an attacker to essentially gain access to the target system, and then they if the target system is running a Linux kernel that falls within the affected versions of the Linux kernel, they can elevate their privileges really, really quickly. The other issue, and this is something that's huge, is that you can also break out of containers, right? Because containers run on the Linux kernel that's on the host operating system. So if the host operating system kernel is vulnerable, then you can essentially break out of the container. So I'll also be making videos covering that. But if you remember or go back to my Docker security training series, I actually highlighted this quite a lot, and a lot of people were actually saying, well, there's very few Linux kernel vulnerabilities that allow privilege escalation nowadays. I don't see, why we actually need to make sure that our Linux kernel is hardened and updated or doesn't suffer from any vulnerabilities, So this is another good example of why you also need to consider the host operating system security, or the Docker host kernel security, if you're working in a containerized or in an environment that utilizes containers, because they are also going to be vulnerable. With that being said, as you can see here, you can check out the GitHub repo for yourself. I'll be making changes to it as I get more information. I'll probably also add a couple of more exploits that highlight how this works, and I'll be adding just some additional documentation. And yeah, so thanks a lot for watching, guys. I really appreciate the support. I apologize for not having not resuming normal uploads, but I've had a very busy couple of months, but everything is looking good now, so I think we're ready to continue. So yeah, thank you very much for watching. If you have any questions or suggestions, leave them in the comment section. If you want to reach out to me, you can do so via my Twitter account. The link to that is in the description. You can also join the discussion on our Discord server and our forum. The links to both of those are also in the description, and I'll be seeing you in the next video. Peace. I just want to take a couple of moments to thank our Patreons. Thank you, Michael Hubbard, Dustin Umpress, Jerry Speds, Doozy, Sid Saab, Ryan Carr, Shamir Douglas, Jojo Bibi, Palangos, Kush Kev, RS, Nino Buikov, and David Bricker. You guys are really awesome. Thank you very much for supporting us, and you guys make these types of videos possible. So we really appreciate it, and we look forward to producing even more high quality content.